Okay, morning, Master Mason. No, so last night or yesterday we were doing the hardest problems in physics, right? Um, and quantum physics, and so we last night we're talking about what makes the hardest problems in physics because this is the mathematical variable, and hopefully you understood me talking about the pallet setup. Like, take the factor out that you walked it up to the building, you picked it up off the ground. There's just rotations of because you missed the inventory set. You're close to an area on a thing. You have to now computate that factor plus the standard factor and any drag time that would be into there. And you wind it. It's a nightmare. M1, M2, Mn. You have to eventually, even though it seems like it's limited, you have to kind of go through that and really kind of determine which ones of those it are, because there's going to be an output on the end. Is it how much of that inventory? Is it 5 before it, before you go down and do that? Is it 15? Is there a margin of error on that window? Because if they were out in that box, same deal with wedges and pallets and everything else. M1, M2, Mn. Yeah, because they're the same problem, ain't they? And then wave collapse. All right. But so this morning I saved one from last night. I saw one. It's like, what is the hardest problem on the SAT? And we're going to talk about that problem. It involves two circles. Circle A is smaller than circle B, and then they give you some multiple choices on the SAT from a few years back. Go watch Because Science, the SAT question. There's my plug. But this is something I've done before, and so on the ASVAB, there's one about gear force, or how many teeth it needs, or how many rotations given the teeth of the, is how you do that. And it's actually a pretty difficult question in terms of the engineering house. But this one's a pretty straightforward system. Now, there's a couple other ones in mathematics you might want to do with this. 3 red and 2 blue. They do a few of them like this. They have the hardest math problem on the hardest tests. It's a 12 question test, section A and section B stuff. And so section A, ball B, how many forces? See, the truth of the matter is I could be looking at it from B's position and say, that's that surface area, because this is essentially a curvature problem. I don't know if it's saddled. I don't know really any of that thing there, but I have to be able to tell the distance of the universe by this curve, right? And nothing else to determine that, and that gives me the full rotation, the full radiant of that. And if I tell the area, I can tell you how far light travels across it. I could tell you from this point here to that point over there, definitely. But if the curvature problem creates like EM fields of air turbulence or fluid dynamics in that system, then it makes those computations a little off, as long as they're not too far out of general, or where the calculation, get the little computer out, renormalize that thing, because all the numbers would be same except for 1 or 2 factors. New alien planet around here, the Death Star that's out there maybe, but everything else still works. All right, so that's the kind of nature of, and then SAT, why do I take a question like that? What does it correlate to in the world? I mean, if nobody got it right there, they've probably never used it since. Is there any job where this practically applies itself? This is the number of the distance that travels around. Okay, that's the truth of the matter. You could quantify that in a stone mill. You can quantify that for gear forces and mechanical engineering and say that's what this question is supposed to symbolize or represent. But when you're actually working the fucking gears, you're not limited to simple tools like just a calculator. A cell phone is going to be that different force here. Here's the service number on that. This is what I want it to go in. They already know what the output on that is. Let's do that. If I was making something, whittling that thing out the back door, realistically, the surface of that becomes a plasticity problem of steel or plastic gears for a long-term housing problem and something like that. That becomes the number. I just don't ever see it being taught that way. To find the simple mechanics that goes into that, there's a lot of ways to process people with what calculus is. All the forms of all circles from any calculus point on those things, and you're supposed to tell me that what you're trying to tell me is that, and then you're going to tell me the engineering bit with it. It's like, no, this is about gears and planetary models and satellites and yeah, topography and altitude on the mountain. Yeah, that's some bullshit. Because you ain't given that. Again, for me, like I said, there's a few other problems that you really need to understand that problem correctly. The SAT is one of these things when you look at that math problem in itself, it's like the SATs, it's a one shot Johnny. I never took them. It's not necessarily standardized in the fact that everybody takes that standard test, so therefore it reflects that. Or everybody's going to be mechanical engineers, or everybody's going to be. So a doctor's got to get that standard on the math test that reflects a grade of something that when you get there is super discriminative against, what you actually do all day. That's the distance around the circle. That's the surface of the black hole. When you get into black or gravity wells and stuff like that on the surface of the black hole's area, I'm talking about, whether it's a neutron star down there, just with enough nuclear spaghetti going on there to black it out, mass out the, just that number. Essentially, that's what they all file down to, but it's obviously much more nuclear spaghetti. In order just to break that kind of limit like that, I was like, I don't mass out the world. It's like, I'm sure the same concepts of nuclear spaghetti are happening in me in some level. Which one, I'm not quite positive. It certainly applies when you talk about stuff. Blacking out this, it's a moving ball, everything that I just said, and you're setting it on another moving ball. So you get two balls in Aristotle's common sense physics, right? You drop one in air, you drop one in water. That's the distance around this surface. In a way, they're the same problem. To mechanically work that thing, though, it's easier to do it in physics than the mechanics of mathematics. It's a, if you could have those measurements, get it in there. I don't know what machine you're building where the tolerances on that thing are so tight that you have to figure this out for the first time like that. And I'm going to say that because there's a few inventions. Like, there's one that's like this big long pole. I think because science talked about this one before, it might have been space-time. But it tells about the gravitational something or other. It's this big long stick with weights on it and stuff like that. And this guy made it to prove something about gravity, right? Obviously you had big grants, big money coming in here. Unless you had money in your kind of pocket like that, ball A or round ball B worked out. So find one. And that's what somebody's going to try to sneak you off like that. That's great. Pick one up and put one in your pocket now that you know what it is comparatively, where you've never had a problem with this before. That's to say geopolitical politics didn't matter, I guess. A little bit, some of that stuff sometimes with that testing. I've got big numbers on the ASVAB, ball A, ball B, area under the curve sometimes. That surface is these tools that I'm determining to find the area, and then you get into some shade problems in calculus. You want to brute force me, work like that, I'll brute force you one back. Well, it becomes a big thing. What time kids are ready, what times that integrate the workforce, how does that workforce system integrate the old school models and veer Kurt, hopefully you got some kind of sensible model about that. Somebody who can track all kinds of different numbers, not just something that had to be fit for OSHA, MSHA, rich or otherwise. You find out physics would apply better. If you do the calculations for somebody in that standard, then I'm not really adjusting for, I have to count somebody or something as gravity. I should be able to reverse engineer it all from here, and then that would be the effect that gravity shows. That's how physical bodies move. Even though we're not necessarily those kinds of objects, we do follow the same rules. That gravity becomes certain numbers. Rich isn't this 100% of the time, always. It's a number you have to quantify for in this time. He's always a number. And this number correlates to other numbers on the graph. So if he was the ball that had to travel around, I could tell you based on whatever I saw on the surface of that thing what this correlates to. And again, we're getting away from mechanical engineering. However, this is about the SATs and the area that the ball A travels around the surface of ball B. So what is ball B here? What's the end result? So colleges, and colleges are definitely not limited to systems quite as marginary as A and B. There's a lot of MP problem. There's a lot of Hunter's Prize still floating around out there, so you have to look at SATs like he's like he said this from the 1840s or whatever. But there was one when I was graduating the Regents. A lot of people had a hard time doing that every year. And then you have to ask yourself, what did it really do to change Common Core in the schools? I was there every year. I didn't necessarily see anything different once you found out the number of the area around the surface that it applied to what you could do much differently for the teaching syllabus. There's standard model, do the job, or just, come in and clock in every day and try to teach these damn kids anything, right? Hold them down. There's all kinds of different problems of that surface of the black hole issue. Catch you on the next one.